Tutorial 2B in question 1 goes as follows. The top of a gold mine, a pressure gauge reads 0 kilopascals. And the same pressure gauge reads 60.087 kilopascals at the bottom of the mine. What is the approximate depth at the bottom of the mine, given that the density of air remains constant at 1.225 kilograms per cubic meter, and the value of G remains at 9.81 meters per second squared? Alright, so we've been given the density of air and gravitational acceleration, and we know that we have two pressure readings, one at the top of the mine, one at the bottom of the mine, and what we're trying to do is determine the value of H, which is the height or the depth of the mine. So we know that pressure, when looking at the height of a column of fluid, can be calculated by taking rho g h, multiplying them together. So that is the density, gravitational force, and the height of the column. So if we substitute or we make H the subject of the formula, we've got P over rho G, and our pressure at the bottom of the mine is 60.087 times 10 to the 3 pascals. We divide that by rho for air is 1,225 and times by 9,81. So that gives us a height 5,000 meters or 5 kilometers deep. Quite a deep mine. Right, point number 2, or section B. A free diver sinks to 150 meters below the surface of the sea. Calculate the absolute pressure measured in bar at this depth if the absolute pressure at sea level is 101.325 kilopascals. So in the previous question we were using relative pressure because we had the top of the mine was 0 kilopascals, but now we're using an absolute pressure. Alright, so this is B. Absolute pressure in bar, 150 meters below the sea surface. Right, so we know that H is equal to 150 meters. The pressure at sea level is given as 101.325 kilopascals, atmospheric pressure. Density of seawater is 1025 kilograms per cubic meter. So absolute pressure is equal to the pressure at atmospheric pressure plus the pressure at the depth of 150 meters. So that would be 101.325 times 10 to the 3 plus rho GH. So that is 101.325 times 10 to the 3 plus 1025, which is the density of seawater, times G, 9.81, times the height of 150 meters. So our absolute pressure would then be 1609.61 kilopascals, or 16.096 bar.